In this video, we'll look at implicit differentiation. That's section 2.6. Implicit differentiation. When we differentiate both sides of the equation with respect to x, and then solve the resulting equation for the derivative of y. Don't forget that we'll need to apply the chain rule as we use implicit differentiation. Why we need implicit differentiation. And this, probably anything else in the video, might be what you're going to find the most helpful. Notice for all the examples we had before, we were finding the derivative of f of x. For example, f of x equals x to the 7th plus 3x to the 5th minus 2x plus 9. But notice it was solved for y, because f of x is the same thing as y. All the examples we've done before were either written in this form with a y equals or written in this form with f of x equals, which is the same thing either way. It's just two different notations. For y, what makes this example 1, 3x to the 5th, y to the 9th equals 201, what makes this example very different is that it's not solved for y. Now we could solve this for y. We could equals negative 3x to the 5th plus 201, and then divide by 7 to the 9th root. But that's going to make for quite a messy problem to work with. So we have this other process called implicit. Here's how it works. We're going to do the derivative of each side of the equation, the derivative of 3x to the 5th plus 7y to the 9th, and then the derivative of 201. Let me show you how that would, with respect to x of 3x to the 5th, with respect to x of 7y to the 9th, equals the derivative with respect to x of the constant 201. The derivative with respect to x of 3x to the 5th is just a 15 to the 4th. The derivative with respect to x of 7y to the 9th, we've got to apply the chain rule because we're deriving with respect to x. So that's going to be 7 times 9, 63, y to the 9 minus 1, or 8. But then we've got to do the derivative of y with respect to x. We've got to go back and do the derivative of what it was that was raised to the 9 is a y. The derivative of a constant is 0, so it would look like this. Another way of saying the derivative of y with respect to x is to simply say y prime. So we could replace this dy dx with this notation y prime. The next step is going to be to solve for y prime. So to solve for y prime, I'm going to take this 15x to the 4th and subtract it from both sides. So we have 63 y to the 8th times y prime equals negative 15x to the 4th. All for y prime, I'll now divide both sides by 63 y to the 8th. Answer. Y prime equals negative the 4th over 63 y to the 8th. Actually, I'm mistaken there. It's not the final answer because this 15 by 3. So our final answer is going to be x to the 4th. 3 goes into 63 21 times. So we get negative 5x to the 4th over 21y to the 8th. That's the first example for implicit differentiation. And this may feel really different from what you've been doing, but keep plugging along with the examples and ask questions in class when you need to, eventually this will become easier and easier to recognize. First of all, how do I know when I look at example 2 to use implicit differentiation? I know that I need to use implicit differentiation because it's not solved for y. This example isn't written as a y equals something. We've got an x and a y together on the left side of the equation. I could, for this, for y, and get y equals 1 over x and then do the derivative, but I'm going to go ahead and approach instead. So we'll do the derivative with respect to x of the left side product, and that's going to equal the derivative with respect to the right side. The derivative of 1, that's just a constant. 1 is a constant, so we're going to have a 0 here on the right. So the derivative x of x times y, applying the product rule, we've got x times the derivative of y plus y times the derivative of x, which is just 1. And then we got a 0 over here. I'm going to rewrite this derivative with respect to x as a 1. Derivative with respect to x of x is just 1. So when I go to solve this for y prime, I'm going to subtract y from both sides and then divide by x. Prime is the opposite of y over x. Let's try another example of implicit differentiation. We're going to go down to this example. 2x cubed plus x squared y minus xy cubed equals 2. So we'll do the derivative with respect to x of this piece on the left with respect to x of this piece on the right. The derivative of 2x cubed plus x squared y minus xy cubed. I'm going to try and show this in color so that we don't lose any pieces. We've got the derivative of 2x cubed. That's probably the easiest piece here because we're simply applying the power rule. So 3 times 2 is 6, x to the 3 minus 1, or 2. Next, I've got to do the derivative of x squared y. And this is going to require using the product rule. So if I were to do, I'm going to do this off to the side, the derivative with respect to x of x squared y. That's the first times the derivative of the second plus the second times the derivative of the first. So applying that, the derivative of x squared y would be the first x squared times the derivative of y. The second, that's the y, times the derivative of x squared. So this piece here, the x squared y prime plus y times 2x is the derivative of x squared y. Next, I'll have to do the derivative of xy cubed. I'm going to be really careful with my subtraction here, the xy cubed, so I've got to subtract this whole piece. So let me keep this as concise as I can by showing that we've got 3 different pieces. First, we had the 2x cubed. Its derivative was 6x squared, and then the derivative of x squared y is green, and then the derivative of xy cubed, we're going to have the first times the derivative of the second. Now we do the derivative with respect to x of y cubed. We've got to do the derivative of something cubed is that 3 something squared. But then I've got to go back and do the derivative of that something, the derivative of what it was that was cubed, so the derivative of y. So when I do the derivative of xy cubed, I've got the first x times the derivative of y cubed. The derivative of y cubed will be 3y squared times the derivative of y. So that's the first times the derivative. The second, the y cubed, times the derivative with respect to x, which is just going to be 1. And then I'll have this equal to the derivative of 2, which is, let's go back. We'll have a lot of things to simplify here. Let's keep this nice and neat here. So we'd have x squared plus x squared y prime plus 2xy minus 3xy squared y prime plus, now remember when we did this derivative of xy cubed, we got this whole piece here, and when we did the derivative of x with respect to x, that just turned into a, so what we have here, our last piece is the y cubed. So we have 6x squared plus x squared y prime plus 2xy minus 3xy squared y prime plus y cubed. Mistake I've made by neglecting that this was distributed, it's the opposite and then an opposite. So I have to be careful to show that this should have been subtract the y cubed, because that subtraction was distributed. And this equals 0. Do you recall what the last step is? The last step goes back to basic algebra 1, which was to solve for y. You don't always have to show all of these steps, but this time around, just to make sure we've got everyone on board, I'm going to show each of the steps for solving for y prime. The first thing I'm going to do is put the y primes together. Let me not write it as a product yet. So we'll have y times x squared, and we've got minus y prime times 3x y squared. So here's the two y prime terms. Y prime times x squared, prime times 3x y squared, and that was a subtraction. And then we've got a 6x squared, 2xy cubed equals 0. So the first step is going to be to move the 6x squared, the 2xy, to the other side. So I'll subtract 6x squared, subtract 2xy, add y cubed, and I'll have y prime times x squared minus y prime times 3xy squared on the left, and on the right, I've pushed everything else over. You have negative squared minus 2xy plus y cubed. Again, I'm showing when you're doing your homework, if you already have this skill down really well that you can solve for the y prime, you might have skipped what I'm showing in the video this time. Next thing is factoring out this y prime. Y prime times minus 3xy squared. And then the last step is to divide both sides by x squared minus 3xy squared. So that our final answer would look like this. Y prime equals negative 6x squared minus 2xy plus y cubed all over x squared minus 3xy squared. Sometimes you'll find that the numerator and denominator be reduced, but we won't worry with checking that this time on this example. So that concludes the video on implicit differentiation. I hope that gives you a good start in how to use implicit differentiation. And when we're in class, we'll do a few more examples together and some more examples in groups with your classmates.